Welcome back to our brain gym. Okay, so in our previous video, we answered these 4 questions. And my philosophy is, if you can do it with a pen and paper, then do it with a pen and paper. Do not pull the calculator too close, too fast, because calculators make your brain lazy. Then you cannot do the simple equations in your head anymore. Okay, so remember we're doing 6 equations in total. 5, starting from the easiest to the most difficult ones, and number 6 would be a word equation. So we will deal with number 6 as soon as we have done number 5. If you want to see how I calculated all of these answers, please go to part 1. There you will see exactly how we've calculated all of these answers. Okay, so let's go to number 5. Number 5 states that 6 to the power of 2 multiplied by 6 to the power of negative 3 multiplied by 6. Okay, so first of all, everybody that sees this beautiful piece of number over there will automatically freeze and say, but hold on, this one doesn't have a power, so how am I going to work this thing out? But it has an invisible friend. Its invisible friend is 1. Okay, so when we see a normal number like this that doesn't have any power along with it, it is equal to the power of 1. Now we can calculate. First of all, we need to write down our rules. What rule are we going to apply here? The multiplication rule. So a to the power of n times a to the power of n equals to a to the power of m plus n. So we're going to incorporate that rule. So we have 6 to the power of 2 plus negative 3 plus 1. Okay, remember we bring in BODMAS, so to help us concentrate, we put the first equation in brackets. So equals to 6. What is 2 plus negative 3? 2 plus negative 3. We flip the number, which means it's 3 minus 2. So 3 minus 2 gives us 1, and because this symbol is actually the identity of 3, we were bringing it down, and we make it negative 1. So 6 to the power of negative 1 plus 1 equals 2. So what is negative 1 plus 1? We do the same equation. We say negative 1 plus 1, and we flip it around. We say 1 minus 1. So 1 minus 1 gives us 0. Right. So then the answer would be 6 to the power of 0. And we're not down there because our next rule states that if a is to the power of 0, it would always be equal to 1. So 6 to the power of 0 equals to 1. And the answer for 5 would be 1. Alright, I hope you guys understand this. We're now going to work out the word equation. I'm going to type it out and then we'll solve that. Okay, so question number 6 states, a cube has a side length of 1/4 centimeter. Show that the volume is 2 to the power of negative 6 centimeters squared, and show that the total surface area is 3 over 2 to the power of 3 centimeters squared. Okay, so first of all in math, we can draw the shape. So let's draw the shape. So automatically a cube has equal sides, right? But it doesn't have just one side, it has 6 sides. This is a very rough drawing. I apologize for the very, very rough drawing here. Okay, so this is the cube that we are talking about. So it has side 1, 2, 3, 4, 5, and 6. Okay, so that is how many sides a cube has. It has a side, 2 sides, one back, one top, one bottom, and one front side. Okay, So we need to know what is the formula for a volume and for the total surface area of a cube. Okay, so we know all these sides are equal, right? A cube has equal sides. That's the nice thing about a cube. Okay, so we're only going to work with one number, but we need to show that the answers of the equations would be equal to this answer over here. So we need to prove that this is correct. So first of all, we need to, how do we prove something? We need to show that it's true, right? So we need to actually work it out. So the volume of a cube equals to side times side times side. Okay, so volume, you need to multiply three numbers together. We have three numbers, and because all the sides are the same, we can also say side cubed, isn't it? Because side times side times side gives you side cubed. Now we're going to incorporate this into our equation. So A starts off, it says side squared, so side cubed, equals to 2 to the power of negative 6. And now we need to prove it. So we have, what is our side? Our side is a quarter, so we have a quarter cubed equals to 2 to the power of negative 6. So how are we going to solve this? Okay, so this is quite easy, isn't it? Because the rule states, your indices rule states that a to the power of m multiplied by n equals to a m times n, and we're going to incorporate that. So there's invisible 1 over there, so it's a quarter to the power of 1 multiplied by 3. So it's a quarter to the power of 1 multiplied by 3 gives us 1 over 4, not the bracket again, 1 over 4 to the power of 3. So a whole thing. And if you need to break it up, 1 to the power of 3 and 4 to the power of 3. 1 to the power of 3 gives us still 1, because 1 times 1 is 1 and 1 times 1 is 1. And then we have 4 to the power of 3. And now if we use the other rule, which states that a to the power of negative m equals to 1 over a to the power of m. Can you see that that one looks the same as here? Which means if we swap them around, we make it to that point over there, we say equals to 4 to the power of negative 3. Okay, now how are we going to change our base to a 2? We know that 4 is a square number, isn't it? Because 2 times 2 is 4, which means 2 squared equals to 4. Now we can change the base into a base of 2. But then we're left with this 2, right? So we have 2 to the power of 2, which is equal to 4, and we still have the index of 3, isn't it? Which means we now need to multiply, because we use this rule. So we say 2 to the power of 2 multiplied by negative 3, and 2 times negative 3 gives us negative 6. So we have 2 to the power of negative 6. And that is how we prove that the volume is 2 to the power of negative 6 cubic centimeters. Okay, and that's our proof. Now let's go to number B. B says, show that the total surface area is 3 over 2 cubed centimeters squared. Remember, surface area means that you have the cube there drawn in all its personality. And we have 4, and then we have 2. one there, and then we have one there. And if we build it, we will get a square. So how many squares do we have? 1, 2, 3, 4, 5, 6. And we need to work out the area. Area is side times side. Okay, so how many times do we need to multiply this side? Because this area is only for this block over here. But we need to work out the area for all 6. So we say 6 multiplied by side times side equals to 3 over 2 cubed. Now we need to prove this. Okay, so how are we going to prove this? We're going to substitute our sides for our length, isn't it? So we have 6 times 1 over 4 squared. Okay, and then it should be equal to 3 over 2 cubed. So then we multiply. As a rule, we multiply only the numerator when we're multiplying equations. So we say 6 times 1 is 6 over 4 squared. Now we need to simplify this a little bit more. Okay, so equals to 6. 4 squared equals to 16. But we need a base of 2. So how are we going to do this? We simplify this further. We divide both sides with 2. Because our numerator is a 3, and 6 divided by 2 would be 3. So we have 3 over 8, because 16 divided by 2 is 8. Now we need a cube, which means we need to cube root 8. Cube root 8. And if we cube root 8, we will get 2. So it will be 3 over 2 cubed centimeters squared. Alright, I hope you understand this. Again, we went from very easy to very difficult, okay? But that is how we need to practice our math to make sure that we actually understand what we are doing. Alright, I hope you enjoyed this exercise. I enjoyed it a lot, and I'll see you again